Got to give the people what they want. All right. Talking about writing exponential equations with fractional exponents. We're going to get this one done. All right, so I figured the best way to do this is just to do practice. So we're going to do 3 practice ones so you all will be ready for class. So write this problem down. Price of a concert ticket was $50 at month 0. 3 months ago, we're going to call month 0. All right, today it's $200. Prices are increasing exponentially. What will the price be 9 months from now? Okay, so just go ahead and write that down. Cool. If you think you know how to do this before me, go ahead and do it. If not, watch and walk through it with me, okay? But this is the time to really learn how to do this. So, like I said, this is month 0. So we're going to write our table. So we have month and we have price, right? So in month 0, it was $50. Today, which is 3 months later, so month 1, 2, 3, it's $200 and it's exponential. So we know that 50 times 4 is 200. Okay? So we know that that's right? So we see that the price doubles, or not doubles, it quadruples. It multiplies by 4 every 3 months. So we're going to write the growth rate and write that out. We say price multiplies by 4 every 3 months. Okay, so that's a thing that we need to notice. It multiplies by 4 every 3 months. So now let's look at how we write this equation. So we know it's times b here, times b here, times b here. All right, so this is the part we know how to do. We know that 50 times b to the 3rd power equals 200 because we're going to solve for b. Right? So we know how to do this. Divide by 50, divide by 50. B to the 3rd power equals 4. Here's the thing, right? To get b to the 3rd power alone, we need to take a cubed root of b and a cubed root of 4. So b equals, we can call it the cubed root of 4, or if you calculate the cubed root of 4, let's go ahead and do that. So on your phone calculator, figure out what the cubed root of 4 is. And the cubed root of 4 is about b equals 1.587. Both of these things are the same. The cubed root of 4, which is about 1.587. So we're going to look at 2 ways to write this, right? So we know that for an exponential, that y equals the initial value times the growth rate to the x. So we're going to do it old school first. So on this one, what's my initial value? 50. So for this one, if we're using this growth rate of b, y equals the initial value, 50, times the growth rate, 1.587, to the x. Right? So this means that each year, the price, because multiplies by 1.587. That's what this one says. And then now we're going to do the other one. We're going to do the new way next to it. So we still have, so if we're doing this one, we still have y equals the initial value, 50, times the growth rate. Now, instead of using this growth rate, we're going to use it in a different form. Root 3 over 4 times x. Remember, these 2 equations are the same. Okay? They're the same numbers. They mean the exact same thing. Now we're going to go ahead and convert this one, though. We know that this also means 50 times, if I put for the cubed root of 4 into an exponential or a fractional exponent, that's 4 to the 1/3 times x, right? That's what we did the other day in class. So if I keep going and I try to get this into a thing that I want, 4 to the 1/3 to the x means 4 to the 1/3 times x over 1. I did that a little wrong. There we go. All right. And so if I keep moving this on down, y equals 50 times 4 to the 1 times x is x, and 1 times 3 is 3. I end up with this, right? So this tells me that this is each year. This one tells me that let me get that here first. Thank you. This one tells me that every 3 years, the price multiplies by 4. That right there. So it just becomes a question of what do you feel like is more useful? I think it's more easy to recognize and understand in your head to see that, oh, all right, these ticket prices every 3 years multiply by 4. And that's what this second equation tells me. But that means the same thing as these ticket prices every 1 year multiplied by 1.587. All right? But this is the way that we're trying to get you, and by we, I mean me, is trying to get you to learn how to do now. All right? So let's do the next one. City population growth. Write this one down. A small city starts with 50,000 people. So you just got to write city starts 50,000. After 6 years, population is 150,000. What is the population after 18 years? Okay, right now we're just setting these up and making the equations. So, let's go here. Let's go ahead and write. Actually, pause. You try to do it. You try to do it before me. Show the growth rate in 2 different ways. See if you can do that now. Cool. You tried it. Now let's see if what you did is right. Or if you weren't ready to do it on your own yet, do it with me now. So I have a city. We're talking about years. And we are talking about population. Right? And at year 0, there are 50,000 people. Year 1, 2, 3, 4, 5, 6. Year 6, there's 150,000 people. How's this thing growing? From 50 to 150, that's 50, 100. This is times 3, right? 50,000 times 3 is 150,000. All right? So I can see every 6 years. So I can see this, that every 6 years, the population multiplies by 3. Okay. So let's start making my equation. So I'm going to go times b to get here, 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 and times b to get here. 1, 2, 3, 4, 5, 6. So I'm solving for b. So I know that 50,000 times b to the 6th power should equal 150,000. I'm going to go ahead and solve for that. Divide by 50,000. Divide by 50,000. B to the 6th power equals 3. Yep. Okay. So now I'm going to keep solving for b. What kind of root do I take if b is to the 6th power? I have to take a 6th root. So I have to take a 6th root. So now I'm left with b equals the sixth root of 3. So b can either equal the sixth root of 3, or if I calculate it, go ahead and calculate what the sixth root of 3 is. Let's see. Sixth root 3 root sixth. A sixth root of 3 is basically 1.2, which is 1.2, right? So the sixth root of 3 is about 1.2. So those are the same. All right. So now let's figure this out both ways. So first of all, if this is my growth rate and this is my growth rate, and I'm remembering y equals initial value times the growth rate to the x. So y equals initial value 50,000 times the growth rate 1.2 to the x. That's the old school way that we did it, right? And so this means each year, the population multiplies by 1.2. And now we're going to do the other way. Y equals initial value times growth rate to the x. But we're going to use this growth rate up here. So this one says y equals initial value 50,000 times the growth rate sixth root of 3 to the x. Now with this one, we got to do a little mathematical, algebraical manipulation. So we go, y equals 50,000. The sixth root of 3 is 3 to the 1/6 power to the x. All right? And let's do a little more algebraic manipulation. Let me move this down and give me a little more space. Y equals 50,000 times 3. And remember, this is the power rule, so these just multiply. So 1/6 times x over 1. So I end up with y equals 50,000 times 3 to the 1 times x is x, and 1 times 6 to the x over 6. And now this one tells me that every 6 years, the population multiplies by 3. The growth rate is 3. All right, two different equations. There's one, there's the second one. Two different ways of telling me the same thing.